In this section, we're going to be looking at logarithmic functions. And we're hitting SL student learning outcome number 1 and number 2. So the module learning outcomes we'll be discussing will be find the inverse of an exponential function. That's what a logarithmic function is. Convert it between logarithmic and exponential forms. Evaluate logarithmic functions including the common natural logs. Graph logarithmic functions, and apply the basic property of logarithms. So, let's talk about solving basic exponential equations. And you want to recall that exponential functions are one-to-one with a domain of all real numbers, a range of 0 to infinity. This means if b to the u equals b to the v, then u equals v. Or in other words, if the bases are equal, we can set the exponents equal and solve. So if I look at problem number A here, they're asked to solve. I look at this for the x equals 16, I can rewrite 16 as 4 to the second. That means because exponential functions are one-to-one, x has got to be equal to 2. For b, if we look at 343, if I take 3 times 3, it's 9, times 3 is 27, times 3 is 81, times 3 is 243. That tells me that 3 to the 5th power, because I have 5 3's here I'm multiplying together, is the same thing as 1/3 to the x. Now the bases here are not quite the same. In order to make it the same, I need to flip this, and the way I do that is by changing the sign of the exponent. So this would be equal to 1/3 to the negative 5. And that tells me that x is equal to negative 5. Here I can do the same thing for c. 5 times 5 is 25. Times 5 is 125. Times 5 is 625. So we have 1, 2, 3, 4 of these 5s. So that's the same thing as 5 to the 4th power. That tells me x equals 4. I can do this here with 8, 2 times 2 is 4, times 2 is 8. So that's the same thing as 1 over 2 to the 3rd, which I can use my negative exponent to write that as 2 to the negative 3. That tells me x equals negative 3. So that's how we work out parts A through D. Now for part E, and also for part F, you got to remember that the range of my exponential is the positive real numbers. So 6x equals 0 can never be solved, because 6 to the x has to give me a positive number. So this has no solution. Likewise, 5 to the x cannot be equal to a negative number. Now let's suppose we want to solve 4 to the x equals 13. The problem is 13 that it's not a perfect power of 4. We can make a conjecture that x should be between 1 and 2. Since 4 to the first equals 4, and 4 squared equals 16, and 13 is between 4 and 16. We could try some values for x. So I could go halfway between 1 and 2, try 1.5. I get 8. That's too low. But now I know it's between 2 and 1.5, so I could do 1.75. Again, that ends up being too low. Alright, so now we know it's between 1.75 and 2, halfway again. Add the two numbers and divide by 2. I get 1.875, and that's too high. And then I could average these two and do 1.8125 as my power. And I get something too low, and I could keep going. Now, the problems is that this method really stinks, because it would take us quite a while to find that x was equal to 1.85021985 blah blah blah. And this process is far too time consuming. We need to develop a better method for solving this equation. And that's what we're going to be talking about in this section, the next section. And the key here is recall that if a function is one-to-one, then it has an inverse function. Since an exponential function is one-to-one, then it has an inverse function. We call this inverse function a logarithmic function. So here's our definition. For x is greater than 0 and b is greater equals 0 and b not equal 1, then f of equals log base b of x if and only if x equals b to the y. This is called a logarithmic function with base b, and x is called the argument. And we've seen this before. If you switch around x and y to get the inverse function, the domain and range get switched around. So the domain of the log function is positive real numbers, and the range is all real numbers. And you want to think the logarithmic functions as asking the question, by what power f of x do we need to raise the base b to get x? So, in other words, what you're thinking about is that any time I'm taking the log of something, it's spitting out an exponent as an answer. So my exponential form would be argument equals base to a power, and logarithmic form would be power equals log base b of the argument. And we want to practice going between these two forms. So let's hop to our workbook exercises, and let's try some of these problems. Sorry, the pages are sticking together today. So here what I want to look at is using this definition of log. Again, I'm going to write it a little bit differently than the way the book writes it. I'm going to write power equals log base of the argument. So that is the log form, and then we want to convert this to exponential form. For exponential form, it's going to be argument equals base to a power. And we want practice going between both forms. Now we're not trying to solve this. All we're trying to do is rewrite it in the other form. So I'm starting with the log form. 2 is going to be my power. My 4 is going to be base. You can always tell that it's always 4 should always be shifted down. The base will always be shifted down. So it's kind of like that at the bottom is like the base. And then this is my argument. So I'm going to rewrite it as argument. Argument is 16. Four is my base. My power is 2. So the exponential form would be 16 equals 4 squared. And it doesn't matter if you write it that way or you write it as 4 squared equals 16. Let's try number 2. So again, I want to rewrite this in exponential form. I'm not trying to solve it. So we're going to identify our base. That's 5. Power to -1. Argument (0.2). Let's try the next one. So my base here is 8. My power is 0. My argument is 1. So we're just going through translating. For number 4, 23 is my base. Let's see if I can write that 23 a little bit better. My power is 0. And my argument is 1. Now let's practice some going in the other direction. So this time I'm given the exponential form and I want to write in log form. Again, I'm not trying to solve it or anything like that. I am just going through and writing in log form. So we're going to have this equal log of something. So my base here is 2. So that has to go here. Make sure you write it below the line of the log. My power here is 4. And remember, the log's giving you an exponent as an answer. And so then my argument is 16. I think I might have my colors backwards, but that's okay. Yeah, I reversed my colors. My bad. I think the power we were doing in dark blue. My bad. There we go. And now usually, if it's a single number like that, they usually don't write the parentheses around the 16. So you'll see it written this way as 4 log base 2 of 16. But right now we're just practicing writing it in log form. So if we look at number 6, my base here is 27. My argument here is 3. And the power here is this 1/3. Let's try this next one. For this next one, my base is a negative 1/4. Again, I'm just following this pattern up here. Taking from this form to this form. My argument here is 16. And my answer is going to be negative 2. Let's try number 8. So here my base here is this 10, so this would be, oops, wrong color, my bad. Log base 10. And in a moment, we will see that this is known as the common log. My power here is the negative 3. and then my argument is 0.001. So problems 1 through 8, we're just making sure we can go back between the two forms. And this needs to be instantaneous. You need to have this down. This is critical for the rest of the chapter. All right, so let's do some actual evaluating logarithmic expressions. So my base here is 12. I'm trying to find out what the power is. And that's got to be equal to 144. Well, if I do 12 times 12, that gives me 144. So this is the same thing as 12 to the second. That tells me that question mark has to be 2. So this answer will evaluate to 2. Let's try this next one. We have 64, so I'm looking at this 64, and I'm trying to figure out, what do I have to evaluate 64 at to get 144? Or, sorry, I don't know where 148, my bad. Looking at problem number 9, my bad. Now, just a quick reminder here. If I take the nth root of some number p, that's the same thing as p to the 1 over n power. So if I take the square root of p, that is equal to p to the 1/2. And I want to take the square root of 64. So this would be 64 to the question mark. And here, this 8 is the square root of 64, which is the same thing as 64 to the 1/2 power. So notice what I'm trying to do when I'm trying to figure these out. I'm trying to write so my bases are the same. That means my question mark has to be equal to 1/2. So my answer here would be 1/2. Let's try this next one. So here my base here is 3. Again, I'm trying to figure out what this exponent has to be to give us 1 over 81. 81 is 3 times 3 times 3 times 3, or 3 to the 4th power. But I have this in the denominator, I want in the numerator, and what I can put in the numerator is I can go and I can change the sign of the exponent. So what I'm using here is the fact that x to the negative n is the same thing as 1 over x to the n. That's the definition of negative exponent. This means question mark has to be equal to -4. And so that would be our answer.